Okay, I want to find the area between curves. And so in this particular case, I'm given three functions. I've got f, g, and h. And I went ahead, first thing I've got to do is I've got to graph it, and I've got to get an idea of what's going on so that I know how to set up my integrals. So looking at the area between these curves, I get this function here, bounded by the green. And so one thing that's kind of interesting, if I'm looking at it, is I'm going, okay, if I'm more towards the left-hand side, and I take my slice, which is going to be my really narrow rectangle, okay, the height of that particular slice is just going to be x to the 1/2. But if I come over here, more towards the right-hand side of this area, and I take my other slice, I'm going to see that this is a different height. This is not just x to the 1/2 anymore. I'm going to have x to the 1/2 minus, and I'm going to have to subtract that straight line, that g of x. So I'm going to have to subtract x over 2 minus 3/2, that quantity. So what I've got to do is I've got to break this into two different integrals. And I can see right here at x equals 3 is where I'm going to have to break those integrals apart. And then let's just go ahead and make sure we know this is x equals 9. So let's set up our integrals. First off, I'm going to go from 0 to 3. I'm going to add up all these little rectangles from 0 to 3, and the height of those rectangles are going to be x to the 1/2, and then we're going to multiply by the width, which is our dx, and that's going to give me the area to the left-hand side of x equals 3. Now I'm going to go from 3 to 9. My x is going to go from 3 to 9, and I've got to figure out the height of that rectangle. Well, that is x to the 1/2 minus the whole quantity, x over 2, minus 3/2. And I'm going to multiply that height by the width of my rectangles, which is dx. And now I should be good to go. So at this point, all I need to do is I just need to evaluate these and crunch the numbers. So as I take the x to the 1/2 and I find that antiderivative, I'm going to go ahead and I'm going to add 1 to my exponent, and then I'm going to divide by that exponent, which is the same as multiplying by 2/3. And I'm going to evaluate from x equals 0 to 3. Now I'm going to go on to the orange part, or the right-hand side. And I'm going to do the same thing. I'm going to find this antiderivative. So x to the 1/2, I'm going to add 1 to my exponent. I'm going to divide by that exponent, which is the same as multiplying by its reciprocal. And then I'm going to have minus, well, I'm going to add 1 to this, and I still have that 2. It was x divided by 2, and then I'm also going to divide by my exponent. So 2 times 2 is in the denominator. And then if you notice, back in the original integral there, I have a minus of that quantity. So I'm going to have to distribute that minus, which is going to give me a plus. And I can think about this as 3x to the 0 over 2. So I'm going to add 1 to my exponent and divide by 1, which is just going to give me 3x over 2. And I'm going to evaluate that. X goes from 3 to 9. All right, so at this point, I just need to plug this in and not make a mistake. All right, 2/3 times 3 to the 3/2, and then I'm going to subtract. Well, when I go ahead and put in 0, that's just going to be 0. And now I'm going to plug in, on the orange part, I'm going to plug in 9. So I'm going to get 9 to the 3/2 times 2 over 3 minus 9 squared over 4 plus 3 times 9 over 2. All right, and then what I've got to do is I've got to subtract and evaluate at 3. So I'm going to end up with, and this is 3 to the 3/2 times, that's the 3/2 times 2 over 3 minus 3 squared over 4 plus 3 times 3 over 2. All right, and now I've got to find a common denominator. I've got to simplify this whole mess. Let's go ahead just real quick, though, and let's look at something right here. Those are going to cancel each other out. Those are the same thing. I got 2/3 times 3 to the 3/2. So those just go to 0. So that's going to make my life easier. I've got 0 here, so that goes away. That makes my life easier. And now let's see what I am left with. All right. 9 to the 3 house. Well, if I take the square root of 9, I get 3, and then I have 3 cubed, which is going to give me 27, and then I'm going to have times 2, and then over 3. All right, my next one, I'm going to get 9 squared, which is going to give me 81 over 4, and then I have 27 over 2. All right, I've got to distribute this minus, so I'm going to now have plus, and I'm going to have 9 over 4. Distribute this minus, and I'm going to have minus, and I get 9 over 2. So now let's see what I get. Let's go ahead and divide 3 into 27, and that's just going to give me 9. So what I get here is I'm going to get 9 times 2 is 18, and it looks like I'm going to have 4 as my common denominator. So let's get all the rest of this. Let's get it over 4. And then this is going to have to be 4 over 4 also. Okay. So now if I go through and multiply all of that, I get 18 times 4 is going to give me 72 minus, I've got 81 plus, this is 54 plus 9 minus 18. This is all over 4, and when I add that all up, I'm going to get 36 over 4, which is going to give me 9. So the area, total area, this pink part here, total area is going to be 9. Now, something interesting can happen with this. We had to break this into two integrals. But what if we looked at the same problem, but in this case, instead of drawing those rectangles and taking those slices and we have them perpendicular to the x-axis, so those vertical slices, what if we were to take a slice horizontally? So if you notice, the thickness of my slice is going to be dy, therefore everything would need to be in terms of y. Would this be easier at this point? Well, let's find out. First off, I have to change all of my equations. Instead of having y equals x to the 1/2, I'm going to have to go ahead and square both sides, and I get y squared equals x. So that's my first equation. Same thing over here. I've got to say, okay, let's change color. Let's say, okay, y equals x over 2 minus 3 halves. If I go ahead and add 3 halves to both sides, x over 2, and then I'm going to have to multiply both sides by 2. And then I end up with x equals 2y plus 3. So that's my next equation. And then this one, let's just hold on a second and let's see. Do I even need to look at that? Let's look at the height of my slice that I did, my pink slice over there. The height of that is just going to be this straight line minus our curved line, right? That's going to be the height of it. So when I go ahead and I set up my integral, I'm going to say, okay, the height of my rectangle is just, well, the straight line is 2y plus 3. Subtract that curved line, which is just y squared. Multiply it by the width of my rectangle, which is dy. And then what I've got to say is, okay, I need to figure out where it's going from. And since everything's in terms of y, it has to be y. So what's my lowest y value? Well, these rectangles I make, the lowest y value is going to come down here at y equals 0. And then what's up here? This is y equals 3. So that is going to be the integral I need in order to find that area if everything is in terms of y. So I'm going to go ahead and figure this out. So I'm going to say, okay, I'm going to add 1 to that exponent, divide by that exponent, add 1. Remember, this can be thought of as y to the 0. Add 1 to the exponent, divide by 1. Well, I don't need to divide by 1. And then I'm going to go ahead and add 1 to the exponent, divide by the exponent, and I'm going to evaluate from 0 to 3. Well, my 2's cancel out. So what do I get? I get 3 squared plus 3 times 3 minus 3 cubed over 3. And then I'm going to subtract, well, when I put in 0 for all these y's, everything goes to 0. So I don't need to worry about that part. So here we go. 3 squared is 9. Plus, well, I have 3 times 3 again is 9. Well, this is 1, 3, so I'm going to take away 1 of those exponents, and I get 3 squared is 9 equals 9. And so you can see in this particular case, the easiest thing to do would be to have one integral and change everything in terms of y. And you get the same answer as when we did it in terms of x. It's just a lot simpler.